Good morning students. Welcome to the physics class, chapter 9, force and laws of motion. So, we will study about first force. What is force? Already you know about force. Force means any action which causes pull, hit or push on a body is called force. Force cannot be seen, but it can be judged only by the effects which it produces in various bodies around us. See, if you want to move the almirah from one place to another place, you want to push it, otherwise you want to pull it. We want to open the door, you want to pull it, otherwise you want to push it. So, while you are playing the football, then you want to hit the football, then only you can play the football. So, any action which causes pull, hit or push on a body is called force. We cannot see the force, but we can be judged only by the effects which produces in various bodies around us. So, we can say that many effects of force are as given as below. What are the effects we can see? First, there is a force can move a stationary body. So, example, one table is lying on your room, you want to move it. You want to move this, otherwise it is a stationary only, table is stationary, but to move this table, we want to push it. So, a force can move a stationary body. Next, a force can stop a moving body. So, while you are driving the motorcycle, you want to stop it. So, you want to apply the brake, then only can stop it. So, next, a force can change the direction and speed of a moving body. Can change the direction. If you want to go from hospital to your house, so left turn will come, you want to change the direction. So, force can change the direction and speed of a moving body. Next one, a force can change the shape and size of body. Means while making the chapati, before that you want to take the wheat powder and add water and nicely mix it. Then after that, while making the chapati, the shape changes. So, a force can change the shape and size of body. So, what is force? Any action which causes pull, hit or push on a body is called force. Force we cannot see, but we can be judged by the effect which produces in various bodies. So, what are the effects we can see? First one, a force can move a stationary body. Next, a force can stop a moving body. Then next one, a force can change the direction and speed of a moving body. Then a force can change the shape and size of a body. These are the effects of forces. Then next there are two types of forces, that is balanced and unbalanced forces. Then we can see that what is unbalanced force. What is unbalanced force? What is balanced force means when the net effect produced by a number of forces acting on a body is zero, then the forces are said to be balanced force. Here you see, from here 5 Newton applied, from there 5 Newton applied, from opposite side there is 2 Newton applied. Then this both sides are equal, that both sides are equal. So, here you will see that what is the resultant forces, what is the net forces, we can see that net forces will be 0. Why it is 0? Because applied the equal forces. From here also 5 Newton applied, from that side also 5 Newton applied, from top 2 Newton, from the bottom 2 Newton. So, there is equal forces applied. So, what will be the net forces? Net forces will be 0. So, what is the balance force? When the net effect produced by a number of forces acting on a body is 0, then the forces are said to be balanced forces. Balanced force means equal forces are applying on 4 sides. So, these are known as balanced force. If applying equal magnitude of forces, then the block does not change its state of rest. Such type of forces are known as balanced forces because we are applying force both sides, but it is equal. That's why it is state of rest. So that will be 0. Such type of forces are known as balanced forces. Balanced forces do not change the following function that we can see. Example, in a tug of war, you might have seen that one competition is there. Tug of war, there is both team will be there. Both teams apply similar force. Both teams apply similar force from both sides. Rope does not move either. Then that is resultant force will be 0. In case it is balanced force. So balanced force means that is equal forces we are applying on from four sides. So that is balanced force means, in an example we can say, in a tug of war, when both the teams apply similar forces from both sides, rope does not move either. So that is resultant force will be 0. So hence it is balanced force. Next we can see that unbalanced force. Unbalanced force means, balanced force means that state of rest. Resultant force will be 0. But unbalanced force means when the net effect produced by a number of forces acting on a body is non-zero. In this case, resultant force will not be 0. This is known as 0, then the forces are said to be unbalanced forces. So we can see the example here. Balanced force, we see that equal force. There if a 50 Newton applied, there also 50 Newton applied. That is balanced force. So in that cases, balanced force is 0. Here unbalanced forces means here 30 Newtons force is applying, here 50 Newtons force is applying. So it's different, means not equal, unequal. So in this case, that is unbalanced force. When the net effect produced by a number of forces acting on body is non-zero, it will not be 0, means that will not be equal forces, unequal forces. In this case, the force is to be unbalanced force. So if an unbalanced force is applied on a moving object, there will be change either in its speed in the direction of motion. But in the case of balanced forces, there will not be change in the speed of the body. But by unbalanced forces, we can see that if applying on moving object, there will be changes in their speed. So, or in the direction of its motion. Thus, to accelerate the motion of the object is unbalanced force is required. Not a balanced force, unbalanced force is required. Why? Because of to accelerate the motion, accelerate the speed of the motion of an object, there is unbalanced force is needed. No balanced force. Balanced force means it will be 0. Unbalanced means non-zero. So to accelerate the motion of the any body, there is unbalanced forces are needed. So now we will study about the Newton's laws of motion. In this chapter we are learning force and laws of motion. Force we have seen, some of the effect we have seen. Next we will study about the Newton's laws of motion. Newton's laws of motion. So Newton formulated 3 fundamental laws. Newton formulated how many laws? 3 fundamental laws. These 3 laws are known as Newton's law of motion. So what is Newton's law of motion? Newton already formulated 3 fundamental laws. What are the laws? We can see that 3 laws we can see. 3 laws we will study. Then first we will study about the Newton's first law of motion. About 3 laws of motion we will study in this class. First there is Newton's first law of motion. What is Newton's first law of motion? Newton's first law of motion means it states that an object will continue to remain in its state of rest or of uniform motion along a straight line path unless an external force acts on it. This means all objects resist change in their state. See, table, example we can see table is always wanted to remain in the state of rest. If external force, if you apply the force, it will move. So, means all objects resist change in their state. So, it states that object will continue to remain in state of rest, means the table want to be in the rest, but external force we apply, what will happen? It will changes its direction, changes the path. This means all objects resist a change in their state. The state of any object can be changed by applying external forces. Then example we can say that a person standing in a bus falls backward when the bus is started moving suddenly. This happens because the person and bus both are in rest, while the person is not moving as the bus starts moving. See that we are standing in the bus. So then suddenly bus started. What is happening? What will happen? So we will fall backward. So why? Because of our body want to be remain in the rest. Then see the legs of the person start moving along with the bus, but the rest portion of the body has the tendency to remain at rest. It want to be remain in the rest, but bus started, suddenly he falls backward, but legs of the person starts moving with the bus. So rest portion of his body has tendency to remain in rest. Because of this, person falls backward if he is not alert. So what is happening? A person, while we are standing in the bus did not start, but suddenly bus starts, what is happen? We will fall backward. Why? Because of we want to remain in the rest. Upper portion of the body want to be in the rest. But leg of the person, what will happen? Starting moving with the bus. Then second, there is example, a person standing in a moving bus falls forward. Your driver applies brakes suddenly. You are standing in the moving bus. Suddenly, driver apply the brake, what will happen? We will fall forward. Then, a person standing in a moving bus falls forward if driver applies brakes suddenly. Now, we want to study about the first law of motion. We want to know, first law of motion, we have to know about the inertia. So, we can see that what is inertia. Inertia means the unwillingness of an object to change its state of rest or of a uniform motion along a straight line is called inertia of the object. So, inertia means that is inherent property of all the objects. Inherent properties of all the objects. So, this Newton's first law of motion is known as Galileo's laws of inertia. So, inertia means the unwillingness of an object, means it does not like to change the position, means table it wants to remain in the rest, that is unwillingness. It does not like, means the unwillingness of an object to change in state of rest or of a uniform motion along a straight line is called inertia of the object. So, inertia always depend upon the measured by its mass. Then, inertia is directly proportional to the mass. It means inertia increase. Inertia means directly proportional to the mass. Inertia depend upon the mass of the body. So, inertia always directly proportional to the mass. It means that inertia increases with the increase in mass. If body's mass will be more, inertia also will increase. The inertia increase with the increase in mass. If there is decrease, then decrease in mass. But decrease the inertia, then increase in mass. A heavy object will have more inertia. Heavy cube, why more inertia? Because of this is heavy object. Heavy object is having more inertia than lower object. So, now we will study about the types of inertia. There are three types of inertia. There is first types of inertia is inertia of rest. Inertia of rest means the tendency of a body to oppose any change in its state of rest is known as inertia of rest. We can say through the example you can make understand, means when a bus suddenly starts moving forward, the passenger in the bus fall backward. Why? Because we want to remain in the rest, But bus suddenly moving, what happen? We will forward. So the second point is the carpet is beaten with a stick to remove the rust particle. If you know at home, you know that the carpet is there full of dust. Always dust want to remain in the rust only, state of rust. While beating the carpet, what will happen? Dust particles will move out. Then third point is when a tree is vigorously shaken, then some of the leaves fall from tree. So you can do this experiment. You will shake the tree. What is happening? Leaves will fall down. Why? Because of leaves. This always wanted to remain in the rust. Leaves always want to remain the rust. While we shaking the tree, what will happen? Trees falls down. Then second there is inertia of motion. The inertia of rust over, then inertia of motion. Inertia of motion means the tendency of a body to oppose any change in its state of motion is known as inertia of motion. Means example we can see the passengers fall forward when a fast moving bus stops suddenly. Then because bus in motion, other case bus was rest. Then in this case bus is motion. So suddenly applying the brake, what is happening? You moves. What will happen? You will fall forward. So a luggage is usually tied with a rope on the roof of a house. Then next we will study this inertia of direction. The inertia of motion. First point we see inertia of rest. Second it is inertia of motion. Third is inertia of direction, not motion, direction. What is inertia of direction? Inertia of direction means tendency of a body to oppose any change in direction of motion. The first we study that inertia of rest means change in state of rest. See, the tendency of a body to oppose any change in its state of rest. That is inertia of rest. Inertia of motion means the tendency of a body to oppose any change in state of motion. This is case state of motion, in that case state of rest. Then inertia of direction we can see that the tendency of a body to oppose any change in its direction of motion is known as inertia of direction. So example, I will make you understand through the example. When a fast moving bus negotiate a curve on the dot, the passengers fall away from the center of the curve order. Which changes the direction. Driver will change the direction. What is happening? Passengers fall away from the center of the curved road. Second point we can see that a stone tied to a string in a whirling in a horizontal circle. If a string breaks, what is happening? The stone flies away tangentially. This is the example we can see that inertia of motion. But inertia of rest we have seen. Inertia of rest we can see that. Inertia of motion we can see. Inertia of direction also already you see that. Next we will study about the momentum. Before the studying about the second law of motion, we have to know about the momentum. What is momentum? Momentum means measures the quantity of motion possessed by a body. Is possessed by body is defined as the product of mass and velocity of the body. Inertia we say that inertia measured by the mass. If inertia increases, what will happen? Heavy bodies having more inertia. Then momentum means it depends upon the mass and velocity. But what is momentum? Is defined as the product of the mass and velocity of the body. So if a body of mass m moves with the velocity v, then the momentum we will say p. Momentum is denoted by p, velocity is denoted by v, then mass is denoted by m. So I told you momentum is the product of the mass and velocity. But p denoted by momentum is denoted by p. But p is equal to mass into velocity. Mass into velocity. You see that what is will be the SI unit of momentum? You know that SI unit of mass is kilogram. SI unit of velocity is meter per second. In last class already we have learned the SI unit of velocity and SI unit of acceleration, these all things. Now we will study about the SI unit of momentum. For momentum is denoted by P, mass is denoted by M, velocity is denoted by V. So SI unit of momentum, how we will find out that? You know that SI unit of mass is M, okay, kilogram. SI unit of velocity is meter per second. So what will we get? SI unit of momentum is kilogram meter per second. So example we can see that one numerical problem. Numerical problem is that a car of mass 1000 kilogram is moving with a velocity of 72 kilometer per hour. Find its momentum. So you know that you already studied about what is the formula of momentum. Momentum means mass into velocity. So P is equal to mv. So here already is given mass. Mass how much given? 1000 kilogram. Velocity how much given? 72 kilometer per hour. So we want to convert the kilometer per hour to meter per second. Then only we will find out the momentum. So first already last class you already studied about how to convert the kilometer per hour to meter per second. So what to do? 5 upon 18 into multiply, you have to multiply with 5 upon 18. So 70 kilometer per hour converted into meter per second. So 70 into 5 upon 18. So what will be the answer? We will get 20 meter per second. So you have to find out the momentum. Momentum, how will find out momentum? Momentum, you know that momentum is mass into velocity. So mass already given 1000. So what is the velocity? 20. So we will get the answer 20,000 kilogram meter per second. So next we will study about the Newton's second law of motion. Newton's second law of motion. First law of motion is over. Next we will study about the Newton's second law of motion. So see, the second law of motion states that rate of change of momentum of an object is directly proportional to the applied external force and takes place in the direction in which external force acts. So we can see first mathematical formulation of second law of motion. You know that body of mass moving with initial velocity u accelerates uniform with an acceleration a for time t. So that is final velocity to v. Then we want to find out the initial momentum. So initial momentum we know P1 is equal to mu, means mass into initial velocity. Final momentum you know P2 means mv2. mv, that is the mass, and v is the final momentum. So change in momentum, how we will find out the change in momentum means final momentum minus initial momentum. So while you get mv into final momentum means mv. So we have written here mv. Then minus initial momentum you know mu. So we can write like this, m into v minus u. Then according to the second law of motion, then force is directly proportional to the P2 minus P1 by T is equal to F proportional to the m into v minus u by T. So you know that F directly proportional to the mass into acceleration. Acceleration you know that A is equal to v minus u upon T. So we can see that here F is equal to, we have to remove this directly proportional, we will remove, then in that place we will write the K. K means proportionality, means K, quantity K is constant or proportionality. So one unit of force is defined as the amount that produces an acceleration of 1 meter per second square of an object of kg as mass. So one unit of force you know 1 k into 1 kg into 1 meter per second square. K you know that K is the constant of proportionality. K is the quantity, is a constant of proportionality. Then thus the formula force can be written as F is equal to ma. So applications of second law of motion. See application. A cricket player moves his hand backward while catching fast cricket ball. This is the example of second law of motion application. A cricket player moves his hands backward while catching while catching the fast cricket ball, what will happen? Cricket player moves his hand backward. During the athletic meet, athletes doing high jump and long jump land on keeper's hand to decrease the force on the body, and the landing is very comfortable. These are the application of the Newton's second law motion. Here we can see that Newton's second law, if the same force is applied on object with a greater mass, the object accelerates at a slower rate because mass adds inertia. So, here in this case speed increases because of mass is very less. So, that is why speed and acceleration is increasing. We are applying the same force both cases. Here there is so many packets, here only one packet is there, here so many packets are there. So, same force applying, here one box is there, so it is easily moved. But in this case, because more mass, here less mass, here more mass, what will happen? We apply the force, what will happen? Speed decreases slowly. So, this is less acceleration than more acceleration. So, thank you.